NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve the floor equation a bracket x bracket plus b bracket y bracket plus ab bracket x bracket bracket y bracket equals k. We will follow the exact four-step algorithm. 1. Rearrange. 2. Factor. 3. Solve for the floor of x and state the divisibility condition. And 4. Analyze special cases. Step 1. Rearrange to group terms with bracket x bracket. Move the term b bracket y bracket to the right-hand side. That gives a bracket x bracket plus ab bracket x bracket bracket y bracket equals k minus b bracket y bracket. Step 2. Factor out the common term a bracket x bracket. We get a bracket x bracket times parenthesis 1 plus b bracket y bracket close parenthesis equals k minus b bracket y bracket. Step 3. Solve for the floor of x. Divide both sides by a times parenthesis 1 plus b bracket y bracket close parenthesis, keeping in mind that bracket x bracket must be an integer. Therefore, bracket x bracket equals the fraction numerator k minus b bracket y bracket over denominator a times parenthesis 1 plus b bracket y bracket close parenthesis, and that fraction must be an integer. Equivalently, a times parenthesis 1 plus b bracket y bracket close parenthesis must divide k minus b bracket y bracket. Example, we will solve the floor equation 3 times floor of x plus 4 times floor of y plus 12 times floor of x times floor of y equals 34. We'll proceed in clear steps and finish by giving the intervals for x and y. Step 1. Recognize the common structure. If we have a times floor of x plus b times floor of y plus ab times floor of x times floor of y equals k, then we can factor a floor of x out of the first and third terms. A floor of x times the quantity 1 plus b floor of y, then plus b floor of y equals k. Solving for floor of x gives the formula floor of x equals k minus b floor of y, all over a times the quantity 1 plus b floor of y. For our problem, a equals 3, b equals 4, and k equals 34. So floor of x equals the fraction 34 minus 4 floor of y over 3 times the quantity 1 plus 4 floor of y. Step 2. Let floor of x equal k, where k is an integer. Then multiply both sides to clear the denominator. K times 3 times the quantity 1 plus 4 floor of y equals 34 minus 4 floor of y. Expanding gives 3k plus 12k floor of y equals 34 minus 4 floor of y. Move the terms with floor of y to one side. 12k floor of y plus 4 floor of y equals 34 minus 3k. Factor and solve for floor of y. Floor of y times the quantity 12k plus 4 equals 34 minus 3k. So floor of y equals the fraction 34 minus 3k over 12k plus 4. Step 3. There is a faster path using a rectangular factorization trick. Start from the original equation and add 1 to both sides. Notice that 12 floor of x floor of y plus 3 floor of x plus 4 floor of y plus 1 equals the product 3 floor of x plus 1 times for floor of y plus 1. Therefore, 3 floor of x plus 1 times 4 floor of y plus 1 equals 35. Step 4. We list factor pairs of 35, including negatives, because both factors must have the same sign. The pairs are 1 and 35, 5 and 7, 7 and 5, 35 and 1, and the negative pairs, -1 and -35, -5 and -7, -7 and -5, -35, and -1. We now enforce that 3 floor of x plus 1 equals the first factor, and 4 floor of y plus 1 equals the second factor. We keep only those pairs that produce integer floors. Step 5. Translate each integer pair into intervals for x and y. If floor of x equals 2 and floor of y equals 1, then x is in the interval 2 to 3, and y is in the interval 1 to 2. If floor of x equals -2 and floor of y equals -2, then x is in the interval -2 to -1, and y is in the interval -2 to -1. These are the complete solutions, since the original equation uses only floors. In this lesson, we will learn a clean, general method to isolate floor of x in equations of the form a times floor of x plus b times floor of y plus c times floor of x times floor of y equals k. We will also state the exact condition that guarantees an integer solution for floor of x. Here is our general equation. We'll keep the coefficients as letters because the steps work for every specific choice of numbers. Step 1. Group the terms that contain floor of x on the left side, and move the b times floor of y term to the right side. We are simply using algebraic isolation. A plus b equals c implies a equals c minus b. Step 2. Factor out the common factor floor of x from the left side. This is the distributive property. A plus b equals m times a plus b. Step 3. Divide both sides by a plus c times floor of y to isolate floor of x. Of course, we must ensure we are not dividing by 0. So we require that a plus c times floor of y is not equal to 0. By definition, floor of x is always an integer. Therefore, the fraction must evaluate to an integer. That gives us the exact solvability condition. A plus c times floor of y must divide k minus b times floor of y. Let us cement this with a quick numeric example. Suppose a equals 2, b equals 3, c equals 1, and k equals 17. Then the expression becomes floor of x equals 17 minus 3 floor of y over 2 plus floor of y. For which values of floor of y does this become an integer? We will test a few integer values of floor of y and watch the divisibility condition. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.